Students, am I audible, ma?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. What are the things which we have discussed in the last class? Anyone can you summarize? We did some problem with conduction shape factor. Am I correct?
Yes, sir.
Okay.
Yes, sir.
So as far as module 3 is concerned, okay, you have to study, especially for cat 2, you have to study infinite solid, semi-infinite and lumped sorry, semi-infinite solid and infinite solid, and similarly this conduction shape factor problems as well as this numerical methods problems. Is it fine, students? Is it fine?
Yes, sir.
Yes,
All
sir.
of you are able to see, even after saying it so many times, you people, you are not following. Okay, so lumped system we have covered for cat 1. For cat 2 we have infinite solid, semi-infinite solid and conduction shape factor problems here. Okay, and how many of you have solved this? All of you have solved this, I think, right?
Yes, sir.
Furnace,
Yes.
what is
Yes,
the
sir.
answer you got? Anyone?
52.37 374 kilowatts.
52.37 kilowatts.
Yes, sir. That's the range.
52,000, 52,374 watts. Is it correct?
Yes, sir.
All of you?
Yes.
Yes, sir. Getting the same.
You can just check this. Anyway, I have uploaded this. All of you, please take a note of it. Those who didn't solve it, please take a note of it. It is 52,374 watts. Okay. And similarly, in the last class we have discussed about especially when we have this finite difference method, or when we have this numerical method. Okay, with the help of numerical method, we can use the finite difference method to solve the problems. Okay, in engineering mathematics, you might have studied that. Am I correct? Am I correct, students?
Yes, sir.
And we also know we also have got this how especially this expression. Okay, and from this expression we have got this t m comma n is this the numerator divided by 4. Okay, so this is there in the data book also. I have shown you. I don't know about the data book, new data book which you have. In the old one it is see, students, I have already mentioned it to you. For the laboratory classes as well as the theory classes, it's must. Please don't scribble anything. Okay, especially in cat 2 exam as well as in the fat examination. Okay, if you have written anything in the data book, it is treated as malpractice. Again and again I say this. Okay, even if you have written anything by now, okay, please put whitener on it so that um, that is it won't come under malpractice if you do that. Okay, please understand that. Please don't write anything. And with convection boundary and with interior node as well as with uh, exterior corner with convection boundary, we have this expressions. Okay, so and I had given you one problem also, right? In that problem, yeah, of course, these theory were there. Okay, whether we can go for the numerical method or not, what are all the things which were there and how we get the equation. Okay, and you can even use MATLAB also. Okay, in the in the matrix form, you can do this and you can get the results. Okay, and yeah, in the form of matrix, right? You can write the equation like this and you can solve and you can get the solution, okay, using the MATLAB. Okay, so usually a problem will be given like this, and I have already told you, if it is given in the examination, then we know that it is very difficult without because it requires so many iterations. Am I correct, students?
Yes, sir.
Yes, sir.
Yeah, so actually we will be having 9 equations and 9 unknown nodal temperatures. Okay, so it involves so many iterations, or we have to use the help of softwares to get the solution. Am I correct? So when it is given in the examination, you are expected to write this equations, these 10 equations. Okay, or these 9 equations. You have nine points. Am I correct, students?
Yes,
Students?
sir.
Am I
Yes,
correct?
sir.
Yes.
So you are expected to write the 9 equations. For example, let me write for the first. Of course, I have told you in the last class itself. Especially for those who didn't attend the last class, just I am refreshing. I will write these 3 equations for T1 for T3 and T9. Okay, I will write these three equations. Okay, so you are expected to write, and there are so many other things which were given in the data book also, right? Is it visible, students? Is it visible?
Yes, sir.
Yes,
Okay,
sir.
so now for first T1, for first T1 we can use this particular formula which is mentioned here, T m comma n. Okay, okay, students.
Yes, sir.
Yes, sir.
So what it is mentioned is T m comma 1, which is equal to 1 by 4 of T m n plus 1 plus T m n minus 1 plus T m plus 1 comma n plus T m minus 1 comma n. Is it right, students? Let me check it
Yes,
out.
sir.
T m plus 1 comma n, T m n plus 1, T m minus 1 comma n, T m n minus 1. Okay, so that's what I have written here. Okay, m n plus 1, m n minus 1, m plus 1 n comma n, m minus 1 comma n. Okay, so when we use this for T1, okay, 1 by 4 of, now Tm comma n is this point. Okay, so we have to take this point, this point T2 and T4. So when we write it, so it is under the assumption this all these surface points were at 500 degrees and all these things were at 100 degrees. So let me take this. Okay, 500 plus 100 plus T2 plus T4. Okay, or students, all of you are able to understand this 4T1, which is equal to 500 plus 100 plus T2 plus T4, or 500 plus 100 plus T2 plus T4 minus 4T1, which is equal to 0. Am I correct, students?
Yes, sir.
So this is what mentioned here. Okay, 500 plus 100 plus T2 plus T4 minus 4T1. Is it okay, students? Am I got that?
Yes,
Okay, and similarly you can write it for other interior points. Okay, so similarly for T2 you can write, for T4 you can write, for T5 you can write. Is it okay, students? Is it okay? So
Yes, sir.
that's what it was mentioned here. Okay, for 1 2 4 5. Okay, for 1, for 1 2 4 5, because these were interior nodes. Okay, for 1, similarly for 2 we can write, okay, T1 plus 500 plus T3 plus T5. Okay, minus 4 T2, which is equal to 0. Okay, so that's what it was mentioned here. T1 plus T3 plus T5 plus 500 minus 4 T2 equal to 0. Similarly for nodes 4 and 5 we can write this. Is it fine? Is it fine, students?
yes, sir.
All of you are able to understand. I am only Charles is saying yes. What about others? Achudan,
Yes, sir.
everyone? Is it okay, ma, for the interior nodes 1 2 4 5? Students,
Yes, sir.
all of you?
Yes, sir.
No,
Yes, sir. Clear, sir.
there are so many members. Shreya, Vishnath, Jeffrey, Ratan, Karudesh. All of you are there?
Yes, sir.
Hello,
Sir,
Karudesh.
sir, I'm we are checking it, sir.
Okay, ma. So, and similarly, now for T3, T6, T7 and T8, we have to use this. Okay, convection boundary. Is it fine? Is it fine, students?
Yes, sir.
Tm comma n. Okay, so let me write for only one expression. Okay, because we have how many points we have? T3 we have, T6 we have, T7, T8 we have. Let me write it for T3. Okay, when we want to write it for T3, we have to use this expression. Can anyone read it? Can anyone read it? Tm comma n, which is equal to, from the data book,
1 divided by h into delta x by k plus 2 whole in the denominator.
1 by h del x by k plus 2.
Plus 2. Plus 2 in the denominator.
Yeah, plus 2 in the denominator. So the whole thing is there in the denominator. Okay, the whole thing is there in the denominator plus what it is mentioned.
H del
Sorry,
x
it's
by
not
k.
plus. It's not plus, into h del x by k. It's not plasma. It's into h del x by k. Yes, repeat it.
T infinity. T
T
atmosphere T
infinity
plus T m minus 1 comma n
m minus 1 comma n
plus 0.5 times of T m comma
okay,
n
okay,
plus 1
plus 0.5 times of plus 0, or let me like the write the plus here, 0.5 times of t
m comma n plus 1
m comma n plus 1 plus again
plus 0.5 into T m comma n minus 1.
t m comma n minus 1. So this is the expression. Okay, now for T3, for T3, for T6, for T7 and T8, we can write this. Okay, and you may ask us a question, what is del x, sir? Okay, what is del x? Okay, now here in it is clearly mentioned in the question. It is clearly mentioned in the question. This is 1 meter. This is 1 meter. Okay, so del x and del y will be 1 by 3 meters. Is it fine? 0.33 meters.
Yes,
Is
sir.
it okay? Is it okay, students?
Yes, sir.
Okay, so similarly, you can write for T3, T6, T7, T8. Okay, when we write, we will be getting this expressions. 2 1 by 3 or 7 by 3 T3, which is equal to 1 by 2 into this one plus 1 by 3 into 100. Okay, students, this is for T3. When you write this in this expression, when you write this in this expression, what happens is this h by k, 10 by 10, it's a constant, 1 by 3 plus 2. So 2 1 by 3 or 7 by 3. This 7 by 3 goes to the other side. 7 by 3 T3. Okay, so 7 by 3 T3. Or all of you are able to understand this, how this 7 by 3 T3 has come? Students,
Yes, sir.
Yes,
h
sir.
value is 10 and k value is also 10 in the question. H value is 10, k value is also 10. Am I right? And del x is 1 by 3. Is it fine?
Yes, sir.
Yes, sir.
Yes,
H
sir.
value is 10, K value is 10. So 10 by 10 gets cancelled. And this is 1 by 3. So 1 by 3 plus 2. So the whole denominator goes to the other side. Okay. So 2 into 1 by 3, T3, which is equal to the remaining thing. Okay. So T infinity, Tm minus 1 comma n plus Tm n plus 1 plus 0.5 of Tm comma n minus 1. Okay. So the whole thing you will be having this. Okay, so this expression is given as T3 equation here. 2 1 by 3 T3, similarly 2 1 by 3 T6, similarly 2 1 by 3 T7, 2 1 by 3 T8. And you can write it and you will be getting this. Is it fine? Is it
Yes, sir.
fine? Okay, and similarly for equation for node 9, okay, the equation for node 9 is you have to use this particular exterior corner with convection boundary. Okay, so this one, exterior corner with this. All of you are able to understand this? Okay,
Yes, sir.
so the final this for equation for node 9 only, it varies 1 by 3 T9. Again, you may ask how this 1 by 3 has come. So it is nothing but here you have this 1 by 2 into H del X by K plus 1. Okay, H value is 10, del X value is 1 by 3. Okay, 2 into 1 by 3 plus 1. Okay, that what it says is 2 into 2 by 3, right? 2 into 2 by 3 is nothing but 4 by 3. 4 by 3 is 1 by 3. So that's what it was mentioned here. All of you are able to understand how this 1 by 3 has come?
Yes, sir.
Is it fine, ma? Or
Yes,
you
sir.
want me to write it?
No need, sir.
No, sir, understood, sir.
Uh, okay. So this 1 by 3, how it has come? Some of you may get confused. Okay. So the thing is, you have this 1 by 2 of h del x by k. We know that del x is 1 by 3. H and k values were 10 and 10. It will get cancelled. Okay. So 1 by 3 plus 1, which is nothing but 4 by 3. So 2 into 4 by. Am I correct? Yeah. 1 by 3 plus 1 into 2. So 1 by 3, 4 by 3 into 8 by 3. Okay, so 8 by 3 means, is it correct? Del x is
Yes,
1
sir.
by 3. Yeah,
It's
okay,
8 by 3 now, sir.
yeah. So finally, we will be having this expression 1 by 3. Okay, so 1 by 3 T9, which is equal to half into T6 plus T8 plus 1 by 3 into 100. So that is the equation which we will be getting for this exterior corner with convection boundary. Okay, so in this problem, only this one. Okay, when we take this particular for T9, we will be having this. Okay, and you are supposed to say anyway, assignment 2, I will give you one problem. Whatever software you want to you want to use, you can use it, and you can get the result. Okay, you will be getting first 9 equations, but for the examination, okay, if it is asked for the examination, you are supposed to write the 9 equations only. Okay, but for assignment, I expect you people to use any software, and or if you want to use the iteration methods also, you can use it, and you are expected to find the result. Okay, so the heat flow at the right phase, heat flow at the bottom phase, heat flow, total heat flow, all the things you are supposed to answer. Okay, so the heat flow at the 100 degrees C phase, the heat flow at the right phase, and the heat flow at the bottom phase. Okay, so q out, which is equal to q1 plus q2 plus q3. So when you add all these three, it should be equal to the energy balance 48, qn equal to q out 4843.4 watt per meter. That should be equivalent to q1 plus q2 plus q3. Is it fine? So if you balance this only, then you will be able to get that, that is, your assumption is correct. If qn is equal to q out, or qn plus q out is equal to 0, then only you can understand that the problem which you have solved is correct. Is it fine?
Yes, sir.
Oh, it is slightly lesser. Okay, 4834.3, which is slightly lesser than, so there is a small, that is heat loss is there, but usually it will be equal. Okay, mathematically it should be equal. Okay, for energy balance, qn uh, q1, when we write it mathematically, it should be equal q1 equal to q out. Okay, or if there is some difference, then there is change in internal energy of the particular body. uh, q minus w equal to del u, we know that, right? First law of thermodynamics, right? So there is some quantity of energy is absorbed by the body, so that there is increase in temperature of the body. Okay, there is change in internal energy of the body. Okay, so that particular thing you should know. But usually Q1 minus Q out should be approximately equal. So it is 4834 here, and here it is 4843. Okay, okay, students. There is a small deviation will be there, but more or less approximately it should be equal. Is it fine?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so with this, the module 3 gets over. So as far as module 3 is concerned, okay, for cat 2 we will be having, as I mentioned earlier, we will be having what's that? A semi-infinite solid, infinite solid. No need to study lumped system. Okay, and this numerical methods you will be having, and conduction shape factor problems you will be having. So 4 different sets of numericals you have to study. Is it fine? Is it fine?
Okay, sir.
Okay, so the next module is convection. Okay, the next module is convection, and of course, nowadays, especially in the last 2 weeks in the laboratory, we did the natural convection experiment and forced convection experiment, and most of the people by this time you know what is the difference between natural convection and forced convection. What is the difference between natural convection and forced convection? Ma? Anyone? This is module 4. What is the difference between model 4 deals with forced convection? Of course, model 5 deals with the natural convection. What is the difference between natural and forced? Ma? Anyone? Forced convection.
So forced convection is a process where convection is like help is happened due to a external force, so like turbine fan or
See,
something like that.
convection happens mainly due to the temperature difference. Ma. It won't happen due to the external force. Please understand that. Convective heat transfer is a mode of heat transfer which is which exchanges, or it is a process in which the heat exchanges between a hot surface and a cold fluid, or a hot fluid and a cold surface. Okay, so
Yes, sir.
uh, the velocity of the fluid, right? The velocity of the fluid, if the velocity of the fluid is created by means of an external agent like blowers or fan, then it is said to be forced convection. Okay, in fluid mechanics, you studied about Reynolds number, the effect of Reynolds number. Okay, what is the effect of Reynolds number?
The flow will be
What is it?
turbulent or lap.
Yeah, it decides whether the flow is turbulent or laminar. Okay, up to a certain limit, the flow will be laminar, and beyond it, it will be turbulent. Am I correct? Up to a certain value,
Yes, sir.
right?
Yes, sir.
Okay. So now what happens is when we force the fluid, right? When we force the fluid, what happens is the velocity of the fluid which passes over the flat plate or cylinder or sphere, it increases. So it increases the rate of heat transfer, right? In case of forced convection, the rate of heat transfer gets increased when we increase the velocity of the fluid. Okay. But if the velocity of fluid increases abruptly beyond a certain limit, again, what happens is it affects the rate of heat transfer, which we will be studying in detail. Okay, due to the zigzag motion of the fluid, okay, or due to the turbulent fluid flow. Okay, so the main difference or major difference between natural convection and forced convection is, in case of forced convection, the fluid motion is created by means of an external agent. Okay, it may be a blower, or it may be a fan, or it may be wind resistance, wind blowing at a higher rate. I have told you about the example of internal combustion engines, stationary IC engines, and similarly, when we talk about the internal combustion engines which were used in automobiles. Okay, in case of automobiles, what happens is, especially two-wheeler engines were air-cooled engines, where we will be having the extended surfaces which were known as the fin. Right. So when we propel the vehicle forward at a faster rate, or when we drive the vehicle faster, what happens is the incoming air comes in and takes away the heat energy. Am I correct? Am I correct, students?
Yes, sir.
Well, Okay, so what happens is due to the wind resistance, or since the vehicle is moving at a very faster rate, what happens is the incoming air comes in and takes the heat energy, and the heat energy from the fin material or the engine body is given to the surrounding air. Okay, and after some point, you park the vehicle. Okay, when you park the vehicle, what happens is the engine body will be hotter, but you will be having surrounding air which is at a lesser temperature when compared to the engine body. Am I correct? Am I correct
Yes,
or
sir.
not?
Yes, sir.
Okay, so in that case, what happens is the heat transfer occurs from the hot surface to the surrounding air. Okay, unless otherwise, or it takes so much time so that at some point of time thermal equilibrium exists between them. Okay, so this is a very small example when we take a chilled water from the refrigerator, and similarly when we take a hot water, okay, which is at 100 degrees C, when both the tumblers were when both hot water and cold water, when we keep it in two tumblers, okay, what happens is in one, from the atmospheric air heat energy is transferred to the cold tumbler, and the hot water temperature, high temperature, or the heat energy is transferred to the surrounding atmospheric air in the other one. Okay, there are two cases. Assume that you have cold one and you have the hot one. Okay, from the hot surface or from the hot tumbler, the heat is transferred to the air, surrounding air. Similarly, from the chill water, okay, the heat from the atmosphere flows into the tumbler. Okay, so after some point of time, okay, when you check after 1 or 2 hours, all the three will be at the same temperature. Both the tumblers will be at atmospheric air temperature, and similarly, the surrounding fluid is also at atmospheric temperature. Okay, so that is said to be thermal equilibrium, which you have studied in thermal engineering, engineering thermodynamics. Am I correct?
Yes, sir.
So now, any one of you, can you tell me the process? What happens in case of a hot tumbler, and what happens in case of the cold tumbler? How it occurs, or that is how thermal equilibrium is achieved. How thermal equilibrium is achieved? How thermal equilibrium is achieved, ma? With the surrounding atmospheric air? Yeah, please tell me. Anyone? Yeah, so many students were there. Garudesh, Charles,
Like
Aditya.
with convection only, sir. Like in case of hot water, the hot water releases the heat energy to the atmosphere or the air that is just above it, and then that air moves up.
Okay, very
Natural
good.
convection.
Yeah, natural convection. Okay, what happens
And
in
the
case
same
of
way,
chill water, cold water?
it will absorb the heat energy in the atmosphere, and then
Okay,
it
it
will get warmer.
yeah. Okay. So in case of cold water, what happens is again the atmospheric air is at a higher temperature when compared to the cold water. Okay, so the heat is transferred from the atmospheric air to the cold water. Whereas in case of the warm water, what happens is, as your friend said, okay, the air comes in contact, or from the hot temperature. We know that heat can be transferred from a high temperature body to lower temperature body without any external aid. That is what the second law of thermodynamics say. Okay, there is no need for any external aid. Heat will be automatically transferred from the high temperature body to the low temperature body. So now what happens is, since the tumbler is so hot at 70 degrees or 80 degrees, the air comes in, it touches the surface of the tumbler, and what happens is when it comes in contact with the surface, what happens is there is decrease in density, right? The air gets warmer. When the fluid gets warmer, what happens is its density reduces. When its density reduces, automatically what happens is the high density air which is surrounding, or the high density air fluid particles which is surrounding the warm air, okay, it pushes the warm air, so that what happens is there is a small buoyancy which is created. Okay, small buoyancy force which is created, so that which causes the circulation of the fluid. Of course, when we talk about the circulation of the fluid, it is very much lesser when compared to forced convection. In case of forced convection, we have the blower power. We need the electrical energy to operate the blower so that the blower blows in air at a faster rate. Even in case of internal combustion engines, we have belt which is connected to the engine crankshaft, and this belt runs a drives a small fan. Okay, I don't know how many of you have seen it. Okay, so before the car radiator you will be having a small fan. Okay, the small fan is connected to the engine crankshaft by means of a belt, so that when the engine crankshaft gets cranked, automatically the fan also rotates. The purpose of the fan is to draw in air. Okay, air gets drawn inside so that a small velocity of air, that is a air, an air velocity, that is a there is a airflow is generated, okay, with the help of fan, so the air is drawn in by the fan, so that what happens is you will be having small force convection over the car radiator surface. Is it clear? Is it clear, students?
Yes, sir.
Yes, sir.
Okay. And I have already told you in the first class, okay, since the engineers, as engineers, you have to take some engineering examples, and you have to say that. Okay, so when we talk about free convection or natural convection, buoyancy driven it is, and hot fluids are less dense, so the recirculation of the fluid takes place. Okay, so we know that warm water is having lesser density and cold water is having a higher density, which we have experienced even in our houses when we open both the taps. Okay, the water which is there at the bottom of our buckets will be slightly at a lesser temperature when compared to the top surface. The top surface will be at a higher temperature, or in other words, warm water is lesser denser, whereas cold water will be having the highest density. Okay, so similarly here, due to the difference in density, what happens is the recirculation takes place in case of natural convection, whereas in case of forced convection, it is done with the help of external means. It may be a pump, it may be a fan. Okay, and classification based upon the region of flow: external flow, internal flow. Okay, so in case of IC engine cylinder fins, whether it is internal flow or external flow, students?
Fins, then external force.
Fins is external flow. Very good. Okay, can anyone say some example for internal flow?
Water cooled engines.
Water cooled engines. Okay, very good. Water cooled engines. That is the water which flows inside the engine jacket, so that and again the water is pumped with the help of a small pump. Okay, even let me show some examples to you, because the practical applications is very important, ma. Now, see, listen here. These were the flow of in nuclear reactors, the flow of the hot coolant, right? So again, you can see here convective heat transfer from the hot coolant to the surface, and from the surface to the surrounding water. Okay, so convective heat transfer, a combination of conduction and convective heat transfer is there. All of you are able to see this. This is a small pressurized water reactor which you have studied in power plant engineering, right? So the convective heat transfer takes place from the hot coolant to the surface, and from the surface again convective heat transfer takes place from the surface to the water. So the water gets converted into steam, and it runs the steam turbine. And again, what happens is the steam, the low pressure steam, it flows over the condenser tubes, so that what happens is it loses its heat energy to the cold water which is circulating inside. So that's why I told you the example of hot water in a tumbler and cold water in a tumbler. Okay, so in case of hot water, from the hot water, the surrounding atmospheric air gets heated up, and what happens is the heat transfer occurs from the hot water to the surrounding atmospheric air. Whereas in case of cold water, from the hot air, the heat is transferred to the cold water, so that the water temperature rises and it becomes atmospheric temperature. Okay, so the same thing happens in case of steam generator as well as in condenser. Okay, in case of steam generator, the water gets converted into vapor by means of convective heat transfer, whereas in case of condenser, the low pressure steam gets condensed back to liquid. Is it fine? All of you are able to see this,
Yes, sir.
visualize this, everyone?
Yes, sir.
Yes, sir.
Okay, so the convective heat transfer is very, very important, and you may ask a question, sir. What type of convection here, ma? Natural convection or forced convection? What is this
Forced.
one? What is this one? And what is this one? Why the rotation is there? What it is?
Forced convection.
It is a pump. So when we use a pump, the pump pumps the water, the pump pumps the hot coolant. So it creates a circulation, or a certain velocity is imparted to the hot fluid, and similarly a certain velocity is imparted to the cold water. So that what happens is you will be, so it is an example for forced convection, not natural convection. Is it fine?
Yes, sir.
Yes, sir.
Yes.
Okay. Okay, I hope you have understood the difference between the natural convection and forced convection, and similarly, there are all some more examples also. Yeah, this is the all of you are able to see this, students. Is it
Yes, sir.
visible? Now, what are all these aluminum things, thin plate like things? What is the use of it? What is its name?
Fins.
Some fins. These were nothing but the extended surfaces which surround the engine. The purpose of this is to transfer the heat from the engine body to the surrounding air. Okay, so or the heat is conducted from the engine body surface up to the tip, and at the tip usually the heat transfer occurs. Okay, and we will be having different types of fins. Okay, circumferential will fins will be there, so you can see there at the top also you will be having fins, and along the circumference also we will be having the fins. Is it fine? Again, this is an example for heat transfer, where heat transfer occurs when the vehicle moves forward at a certain rate. Then we will be having forced convection. When the vehicle is stationary, then we will be having natural convection. Is it okay? Is it fine?
Yes, sir.
Yes.
Yes, sir.
Okay. Yeah. And this is what I was trying to say. Okay, so external convection and internal. So in case of internal, we can take examples: nuclear reactors. Okay, flow of water in steam generators, and outflow of coolant into the steam generators are taken as examples for internal flow, whereas external flows fins were taken as examples for external flow. Okay, flow over a surface. And convection is more effective than conduction. Why? It is because bulk motion of the fluid will always be there, right? Bulk motion of the fluid will always be there in case of convection. And the convective heat transfer depends upon the convective heat transfer coefficient value, small h. Okay, small h is the notation which is, or symbol which is used to uh, define convective heat transfer coefficient. And similarly it also depends upon the fluid properties like viscosity. Mu is viscosity, Cp is specific heat capacity, K is thermal conductivity. And similarly, it also depends upon the flow parameters, whether the flow is laminar or flow is turbulent. And similarly, it also depends upon the geometry, solid surface. Okay, solid surface geometry, roughness, everything it depends. And similarly, it also we will be discussing about this. Okay, similarity between fluid velocity and temperature profile. And similarly, what is no slip condition and what is meant by no jump condition, and how conduction and advection takes place, and why it is called as convection, in the next classes. Okay, in the next class we will be discussing about that. And so again, weight is very very important. The Newton's law of cooling is very very important. Q equal to HA del T, or Q double dash is nothing but capital Q divided by A, which is nothing but heat flux, which will be given in watt per meter squared, which is equal to H into convective heat transfer coefficient into Ts minus T infinity, where H is nothing but the local heat transfer coefficient. Okay, so we will be discussing about this in the next class, and we will also discuss about what is velocity boundary layer, and what is thermal boundary layer, and what is the difference, and what is Reynolds number, what is its significance, and similarly we will also discuss about what is the effect of Prandtl number. Okay, all these things we will be discussing in detail in the next class. Okay, and finally what is the difference between velocity boundary layer and thermal boundary layer. So, and what are all the dimensionless numbers which were used in case of natural convection as well as forced convection. Is it fine, students?
Yes, sir.
Okay. After this class I will upload this also, so that you can go through everything. Okay, you can go through the slides, and before coming to the next class, just go through it. Okay, you will be having external convection, and you will be having internal convection. Okay, forced convection, and flow over flat plates, flow over cylinders, flow over spheres, and then similarly we will be discussing about internal flow. Okay, and finally flow over bank of tubes. Okay, all these things we will be discussing. Okay, and I will be uploading this also today, so that you can go through it. Is it fine? Is it fine,
Okay, sir.
students? Okay, ma. Let me stop the recording, and if you have any doubts, okay, you can just message me, or you can just put it here, so that usually I will be forgetting to upload this. That's the problem. Please inform me. Thank you. Thank you. You can leave now.
Thank you, sir.